Hi, and welcome to the Chapter 9 review for statistics, and we are getting close to the end of the book. We have Chapter 9 and we have Chapter 10, so you guys are almost there. Just hang in there. So first of all, we learned about significance tests, statistically speaking, and we are going to talk about confidence intervals and the significance test, which was the main bulk of this chapter. So hopefully you've been reading over your homework comments of what you've been missing and the answer key that I gave on 9.2. And we're going to also kind of just review all the types of questions that are going to be on the test. All right, first of all, we always, in a significance test, you have to set an alpha level. And an alpha level is typically 0.01 if we want to be very, very careful. This is more reserved for like medical conditions or engine failures, things where it could kill somebody if we are wrong. Then we have a significance level of 5%, and this is the most common. So if I don't tell you, we're going to assume it is 0.05. And then we have 10%. And this is more for surveys that it doesn't really matter if you're wrong or not. So maybe like food preferences, different things like that, where it doesn't really matter if we're a little bit off or not. All right. So how do we know when we are going to side with our HO or our HA? So remember, HO is always where P is equal to some number, whatever the percentage is that we assume is the status quo. And then our HA was always P is greater than, less than, or could be not equal to some number. And these two numbers are going to be the same. So same number here as same number here. And it's usually what is assumed to be true. So in like a coin flipping experiment, we used 0.5 because 0.5 would mean a 50%, and we assume coins are fair, and we have to go about disproving that the coin is fair. All right, so once you have your HO and HA, you would calculate the z-score. Then you would find the p-value from the table. And what you do with the p-value kind of depends on what your HA was. So if HA was less than, you use that value. If it's greater than, you do 1 minus the value that you get from the table. And if it's not equal to, you do 2 times that value. If I can draw a time sign. So you definitely need to jot this down, maybe put it on the board for the test so that you can remember which is which, because you don't want to make a mistake here because that's going to change your whole answer. All right, so once you have the p-value, you compare p-value to alpha. This is how we make our decision, okay? So if I were to make an idea of what, or a decision based on what I'd like to do, there are some things that we would compare it to. So if p-value is less than alpha, we are going to reject HO. And if p-val is greater than alpha, we fail to reject HO. And also you should always include a graph. And so if it's a less than graph, your graph should look something like this. If it's a greater than graph, it should be shading to the right, so over here. And if it's a not equal to graph, then that basically means we're shading both sides. So you have to shade the left side and the right side. And that's why we do 2 times the answer here. And when it's greater than, we do 1 minus the answer, because remember, the table always gives us the left-hand side. So if it's giving us the left-hand side and I want the right-hand side, we know that there's 100% probability in there, so that's why we do the 1 minus. So that is the basic review of significance tests. These are one of the most powerful things that we do in statistics. So it's very, very important that you know all of these steps. So even if you have this in your notes already, I would really recommend that you kind of write down this summary like on a separate piece of paper, so that when you're studying, you're not like flipping through all of the notes, but you're focusing on the steps here. Remember that the steps for a hypothesis test are always number one, to tell me HO and HA and my significance level. So you need to tell me all three of those things. The second step is to calculate. So this is the first step, these three things. The second step is to calculate and find the p-value from the table. And the p-value needs to be the correct one, whether it's 1 minus 2 times or what you actually get. Step 3 is to graph it. So all of this, you pick one of these graphs and that's going to be your graph. And then your conclusion is when we actually compare the p-value to the alpha. So this one was step 4. And you tell me if you're rejecting HO and if you fail to reject HO. And if you remember, we always have to include context. So we don't just say the p-value is less than alpha, we reject HO. That doesn't tell me anything. What you have to do is tell me. We'll say like our HO was that the coin was fair. When we reject HO, we say, okay, there is evidence that the coin is not fair because we're rejecting HO. If you fail to reject HO, then you would say, okay, so we fail to reject HO, there is evidence that the coin is fair. And so those are the wording you're going to use. And of course, if it's not talking about coins, then don't talk about coins. Talk about whatever the particular problem was talking about. All right, so hopefully you have an understanding of how to do these. Calculating z-score, you need to make sure you review that formula. And once again, as you do these reviews, when I do the videos, this is not all inclusive because you're almost in 12th grade or in college, so you need to do some of the review on your own. So you need to kind of go through and dig through the notes and find the formulas that are important. Formulas that you have memorized, great. Formulas that you don't, you probably should write down and study them, because this is what learning is all about, is actually studying. All right, the other thing that we talked about in this chapter from section 9.1 is when we actually are finding a confidence interval instead of just a single test. All right, so our interval, we're always going to do, we first of all have to decide the level of confidence. Because remember, there is a table in your book, or actually in the back of the book too, that tells you what the different z values are that you're going to be using depending on what the confidence level is. And once again, some confidence levels that we've seen are the 95% confidence level. The book had you do a 99% confidence level for one of the tests. I've seen it maybe a 90% sometimes. So there's different values, and of course your table has even more than that. And they correspond to some kind of z-star value that we're going to be using. Okay, once again, to review, a p-hat is an estimate of the population proportion. And if you ever see a p without the hat, that is the actual population proportion. And when I'm talking about a population proportion, what I'm basically talking is like maybe the people who favor a certain color, or the people who like this restaurant over this restaurant, or the people who prefer this brand over that brand. Or it could be proportion of, say, working engine parts compared to the total number of engine parts. Those are all proportions. Proportions is just another name for a fraction. So that is something we are looking for, a fraction or a decimal, because you could change a fraction to a decimal. Okay, so our confidence interval formula, we do p-hat. So you have to first of all get a proportion of some kind. So you have to know how many people were in favor of something over how many people were asked. And we do plus or minus. And the z-star value, remember, comes from this value and the table. Okay? And then we do the whole standard deviation thing where we do p hat 1 minus p hat, and we divide the whole thing by n. So this gives us two values because we're going to do this plus all that, and then this plus this all that. And remember, this is one where you work backwards. So you're going to do the square root first, then multiply by this z star value, whatever that ends up being. And then last, you're going to take that and do p hat plus, that's weird, sorry. Let's erase that. Plus the margin of error, and p hat minus the margin of error. Margin of error is another way of saying z star plus p hat 1 minus p hat over n. Margin of error you can calculate as long as they tell you n and p hat and the confidence level. So there's three things you need to find margin of error. Sometimes margin of error is given. That means you don't calculate it. When I was grading 9.1 homework from you guys, some of you, it told you the margin of error, but you went and sat and calculated it anyway. If they tell you the margin of error, don't calculate it. It's told to you. And it usually looks something like this. Oh, it'll say plus or minus 0.03 or plus or minus 0.02 or something like that. When you see that plus or minus something, that's your key that that is the margin of error. And that means you don't need to do this whole calculation. All you need to do is do p plus that number and p minus that number, and you're done. And it's a very, very easy calculation. However, p hat needs to be a decimal. And then you have these two numbers that are decimals. So some of you on your homework did p hat as a whole number, say like 59, and then you did plus 0.03 and minus 0.03, and you got very wrong answers because it should have been 0.59 plus 0.03 and 0.59 minus 0.03, and that gives you more of a better idea of what's going on. There are some wordings that we have to use when we are interpreting the confidence interval, and I always do want you to interpret it. The wording went something like this. We are 95% confident, and that number can change based on what your confidence level actually was, that the true proportion of whatever we were testing, like the people who favor Moe's over Chipotle, or the people who favor Starbucks over Dunkin' Donuts, or whatever it is, okay? We are 95% confident that the true population, or the true proportion of blah, 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 is between some percent and some percent. So you can memorize this, and then for each question, fill in the blank based on what it's actually asking for. These numbers need to go in order. Don't tell me between 90% and 80%. Who does that? That doesn't make sense. Why would you say between 90 and 80? You need to go from smallest to biggest because that's how we're taught to think mathematically and reading-wise. We look left to right, and it needs to make sense. So it's going to be between 80% and 90%, or it's going to be 72% and 83%, or it's going to be between 41 and 48%. That is how I want you to word that, and it needs to be as percentages. Don't leave it as decimals. So don't say 0.48 and 0.52. Go ahead and change it to percents, and make sure that this whole sentence right here, the true proportion of blah, 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 needs to actually talk about what the word problem was talking about. All right, so make sure you do understand what statistically significant means, and I will go ahead and tell you that. Something is statistically significant when the p-value is less than, and it has to be less than, that means smaller than, the pre-decided alpha level. So I do ask you a question point blank on the test where you don't have to calculate anything. I just say, okay, here was the p-value and here was the alpha level. Is this statistically significant or not? So everybody should get this question right, because if the p-value is smaller than alpha, then we say it's statistically significant. If the p-value is bigger than the alpha level, we would say it is not statistically significant. And I'm not going to ask you if the two are equal, because that wouldn't be fair. We didn't talk about that. So it'll either be less than or it'll be greater than, and you have to tell me if it is statistically significant or not. Please don't do any math on this question except for decide what is less than. And then answer the question with just statistically significant or not statistically significant. The other thing that I'm going to ask you about that is not really mathy, but just words as answers, is how can we make a confidence interval narrower? That means smaller in range. So if I want to be very, very confident, so 95% or 99%, and when I run my interval, it is like a big gap, maybe 30%. So maybe I'm between 70% and 100% of people favoring this certain thing. Well, that's a little bit too big, so maybe I want to be more specific and tighten up that range. What are some things that we could do? There's only two things you can do. So first of all, the easiest, well, not the easiest, but one of the most surefire way to fix any stat problem is always to increase your sample size. Increasing your sample size means n is bigger, and when we divide by a bigger number, we get a smaller number that we're adding and subtracting, which means it fixes our margin of error. It makes it a little bit smaller. So we increase sample size. That's a good fix for pretty much everything in stats. That's a little bit close together. Here we go. The other thing you can do if you don't want to increase sample size is to lower your confidence level. So maybe you can't ask more people, maybe you're shy, or maybe you just don't have the funds to do so. So that would mean like going from 95% to 90% or something like that. Or you could go from a 90 to 85%. So whatever confidence level you started with, if your range is too big, then you could go down in confidence. So you are sacrificing some. You're not as confident now, but it is going to tighten up your range a little bit, which makes it more useful. All right, so the majority of your test is going to be, I'm going to ask these two questions, which are questions where you just provide responses. It doesn't actually require math, but everything else on this test is a math test. That means I'm going to ask you to calculate margin of error. I'm going to ask you to calculate a confidence level interval, and I'm going to ask you to do the 4 steps of the confidence test. So read the question carefully, because I do not want a confidence interval if I've asked for the 4-step confidence test. So make sure you know the difference and make sure you know the steps. Once again, if you want to write formulas on the board, I don't have a problem with that, but I will not be putting the formulas up myself. So that means you guys have to get together and decide what formulas do you need and can we stick them up on the board, and I'm okay with that. You will also be given a copy of the tables. So you're going to have your z-score table, and you're also going to have a copy of the z-star table. The z-star table corresponds to like what numbers we use for 95% or 90% or whatever in the confidence table. So I'm going to do really quick for you 2 examples. We're going to do one that is a confidence interval, and then we're going to do one that is a confidence test. Okay, so let's do one real quick for each of those. And if you still have questions, make sure you ask me well in advance. Don't ask me the night before the test. So ask me any night before the night before the test, because the night before the test, I can't guarantee I'll see it in time and get back to you. All right, so let's do a confidence interval question first. All right, so let's say according to M&Ms, let's say there are 20% brown. Okay, so in any given bag, you're supposed to have 20% brown M&Ms. Now, this isn't true. M&M doesn't actually publish how many colors there are anymore because they were wrong sometimes, and statisticians called them out on it. So, let's see. So, out of 50 M&Ms, 6 are brown. Do a 95% confidence interval for the percent of brown M&Ms. So that is our question, and that's what it would kind of look like. All right, so first of all, we have to get p-hat. P-hat is found by doing how many we were given out of how many total. So 6 out of 50 is 0.12. 0.12 is 12%, so our particular bag is in fact less than 20%. But we want to see if our confidence interval would still include 20% so that M&Ms is still possibly on the right track. Basically, we're saying, is 12% too far off from 20% or not? Okay, that's basically what we're doing. All right, so here is our formula. We're going to do our p-hat plus or minus our z-star. And if you remember, for 95%, we use 1.96. That's from that table. And then we're going to do p-hat, 1 minus p-hat over n, which is 50. And remember, we work backwards. So I'm going to do the square root first. So the square root of 0.12 times 1 minus 0.12 divided by 50, and then close up all your parentheses. And I get 0.12 plus or minus 1.96 times 0.04596. So I went out a couple decimal places here. Then I'm going to multiply these two numbers, the 1.96 times that. So 1.96 times 0.04596 gives 0.09 and a bunch of zeros, so that's convenient. I'll just leave it as 0.09. And so now we're going to do 0.12 minus 0.09, and that gives me 0.03. And then when I do plus 0.12 plus 0.09, I get 0.21. All right, so that's our confidence interval. Now we need to write the statement. We are 95% confident that the true proportion of brown M&Ms is between, change it to a percent, 3%, and change to percent, 21%. Okay? We didn't have that big of a sample size. It was only 50, and remember, you're supposed to have at least 40 to be valid. And we noticed that our gap's kind of big, 3 to 21%. That's a big gap jump, like 3% to 21%. That's a big difference. However, M&M's is claiming there's 20% brown, and we can go as far as 21%. So we don't really have enough evidence to say that M&M's is lying if they actually said that based on this particular sample. Okay, so in a confidence interval test, this is what I want to see. What is your p-hat? I want to see the formula. I want to see that you worked out the parentheses first. Then I want to see that you multiply those second, and then you go ahead and add and subtract, and we write the conclusion. So if you show all of this work, all of it, just like I did, then you're going to get a perfect score on this question. If you leave stuff out, like if you go to p-hat and you magically get to 3 and 21, I don't know how you got that number. So you have to give me it, because sometimes if you round to a different number than me, so say like you only did 0.04, go ahead and plug in your calculator. If you only did 0.04, you might get a different number than I do at the end. And so if you don't have exactly the same number as me and you didn't show your work, it's wrong. But if you showed me that you only went to 0.04, or maybe you did like to 8 decimal places instead of the 5 that I did, then I can see why you have a different answer than me, and I can give you credit for it. So it's for your benefit to show your work, so that if you're not exactly what I have, I can still give you full credit. Okay? All right, let's stick with our M&M example. So once again, we are going to assume that M&M said that there are 40 or 20%, I'm sorry, brown. And let's say we have a new sample now. Let's say I had, out of 120 M&Ms, I have 120 M&Ms. I found 42 brown. Is there evidence that I had, not that, I don't want to say that. I wouldn't ask it that way. Is there evidence that the percent of brown M&Ms has increased? And I'm going to ask you to do the 4 steps for the significance test. The 4 steps, once again, are to state alpha, HO, and HA, then to calculate your z-score and your p-value, and then use the back of the book, and then we graph it, and then we state the conclusion in context. Okay? So here's our answer. Because it's M&Ms, our alpha level could have been 5% or 10%. Either would have been okay. Because just about everything I've done was 5%, I'm just going to leave it at 5% to make it easy. So step 1, HO is that M&Ms has not changed. It's still 20%. And HA, because I said, is there evidence that the percent of brown has increased, that is telling me that I want a greater than. So that's step 1. Step 2, we need to find the z-score, but before we do that, I need to know p-hat. So p-hat is the 42 browns that I found out of 120 M&Ms. So on our calculator, we are going to calculate what 42 divided by 120 is to get p-hat, and that's 0.35. So 35% brown M&Ms is definitely bigger than 20%, but is it big enough to say that it has increased? So remember, our z-score is going to be p-hat minus p over standard deviation. Okay, so we have to calculate the standard deviation first, and standard deviation is going to be this 0.35, 1 minus 0.35, no, we don't use 35, sorry, I lied. We are going to use the assumed value for this one. So we're going to do 0.20 and 1 minus 0.20, and we're going to divide it by 120. That's our n value. So let's go ahead and calculate that now. So the square root of 0.2, 1 minus 0.2 all divided by 120 and close parentheses. And I'm going to round that to 4 decimal places here. So that's 0.0365. All right, so now we have all our values. So p hat was 35. P was 0.20. And we divide it all by the standard deviation, which is 0.0365. All right, so 0.35 minus 0.20 in parentheses. Then divide the whole thing by 0.0365. And we get 4.1. And you go to the table in the back of the book now to get the p-val. Remember, this comes from your table. 4.1 is not going to be on your chart. I can tell you that right now. The biggest one on the chart is 3.49. So I'm going to use 3.49's p-value on there because there is no p-value bigger than 4.1. And that value for 3.49 is 0.9998. Okay? It is greater than that I want, not less than. So I have to actually do 1 minus 0.9998, and that gives us 0.0002. Okay? Step 3 is the graph. It is a greater than graph, so it's going to be over here on the greater than side. And step 4 is my conclusion. 0.0002, my p-value, is definitely less than my alpha level of 0.05. So that means I have to reject HO. What does that mean to reject HO? Well, it means that I'm saying the percent is not 20%. So we say there is evidence that the brown M&M percentage has increased. All right, so that is how you show the 4 steps in a significance test. Okay. There are some questions where I tell you what the margin of error already is, and I ask you to find the confidence interval. When I do that, remember, you don't have to do that whole formula thing. You just add the percent to the margin of error and take the percent and minus from the margin of error to get your range of values. Okay? So most of the questions on the test, there are several. I'm talking about maybe 2 to 3 of each. So 2 to 3 confidence intervals, 2 to 3 4-step processes. So you're basically doing the same thing over and over again with just different numbers. So the test is not hard in that sense. And then the 2 things that I ask you to memorize. There's one other thing that you need to know for the test, and then you will have everything that you need to know for the test. You can make a 100 on this test if you actually apply yourself and practice. The last thing you need to review. Can't spell today. All right, so the last thing you need to review is from 9.1 and your homework. These were like the first 2 questions on your homework from 9.1. If you didn't do your homework, I recommend that you go to 9.1 and do those first 2 questions. One of them, I think, was an odd one, so the answer's in the back of the book so you can check your work. Even if you did do your homework, I would go back to that odd one again, redo it without looking at your work to make sure that you can still do it. There were a lot of you who did your work in 9.1, and when I was grading it, you made some algebra mistakes, even though you knew the process, and so you got the wrong answer. Even though you were following the process, you did some algebra wrong. So make sure you review that and that you're not making careless mistakes. This one, one of the questions on the test, I would ask you, what would the sample size need to be? That means I'm asking for n, guys. That's what that means. Okay? If the margin of error were, say, were, say, maybe 5% or 3% or 2%, okay? Something like that. And if you remember, the way we did it is we take whatever the percentage was. So if it was 5%, we put 5%. If it's 1%, I put 1%. And then we put the confidence level. So if I said, what would the sample size need to be if the margin of error were 5%, I got to add a little bit more for, say, maybe 95% confidence. Remember that 95% confidence is equal to 1.96. And remember that we always use 0.5 when we're doing this question. This is not based on the 5% that I said. We always use 5% when we're trying to find a sample size. 50%, I'm sorry. So 1 minus 50. This never changes. This is always how you do it. And then we put the n there, and that's our letter. So we're doing algebra, and we're trying to move over everything to get the n by itself. And we square both sides. And we cross multiply. So we get n 0.05, 1.96 squared equals 0.5 and 1 minus 0.5. And then we divide everything over. And then here at the last step, you could go ahead and stick all of this in your calculator and make sure that you include all the parentheses that I have, or else you're not going to get the right answer. So I'm going to add another parentheses there. So this is basically, if you remember from 9.1, how we get n by itself, or to figure out what a sample size is. So make sure you review this video, maybe rewind this part if you're still stuck on it. And like I said, it was like the first 2 questions from the homework that I assigned in 9.1. And one of them was an odd answer at least, so you can look in the back of the book to make sure that you understand it. So you will have a review assignment homework. And once again, the review assignment homework is going to replace your lowest homework grade from this chapter. And it is going to be due Friday, even though it's not a red day. It's going to be due Friday at 6 p.m. And I'm making it due at 6 p.m. to be on time. So that even after school you can work on it if you need to. And then that way it gives me time to grade it over the weekend before you take your test, because your test is on Monday. So if you are missing a bunch of questions of the review, I'd like for you to know about it. So please don't be late on this assignment so that I can give you some feedback. So that is what your assignment's going to be. It's not required, but you really should be doing it to show me that you are taking this class seriously and that you're doing your best on it. So that is your review for Chapter 9. Lots and lots of math on this test, so make sure you bring a calculator on Monday for your test. No excuses. You need to have your own calculator. And make sure that you are comfortable with that calculator so that you can plug these values in and get your answers. Review the video several times if you have a low grade and you have a tendency to make bad grades on tests, because the more you see this and the more it kind of becomes ingrained in your mind, then more likely that you're going to be doing well. And let me just always encourage you on any kind of test, especially math tests that have word problems, read the question slowly and carefully and break it down and make sure you know exactly what it's asking for so that you answer every single thing that the question is actually asking for. Other than that, I hope you have a good day and a good week.